So the whole reason to look at all those examples is just to put this class in a context. The data is going to be closer to crime in LA. Everybody gets to choose their own data. In past years, we've had spread of HIV in Los Angeles. We've had bicycle ride-sharing data from Washington, D.C. We've had, there was a good one, which was detection, reporting of UFOs, and compared with the amount of alcohol consumed per county. That could have been a really fun project. 2 years ago, shooting was a big thing, right? So there was a couple of people actually did, shooting of black kids in the U.S. So that was also very interesting projects. But it all comes down to data, right? So what is data? So what is your instinctive understanding of what data is? What? Numbers, right? It's information. It's numbers. It's information. It's measurements, right? It's something you go out there and you measure. You say you have some information, that's some data. So let's get a little closer to the technical side. When we actually start programming this thing, we usually start with a single value, right? A single attribute. If it could be something as simple as a number. In computer science, we usually have integers, which are round numbers, versus float numbers, which are decimal numbers. So we'll talk about integers versus floats a lot. And then the other thing left over is either something that's usually a string or a category or just a name. So a singleton is basically, or a single value is just one single attribute. Okay, so those are kind of interchangeable words: attribute, value. Like I said, an integer usually has no decimals. A float has decimals, or it doesn't have to have decimals. And a string is just a collection of letters and numbers, right? So in this case, do you have any reason why this 22.3 is different than this 3.2? Why is this 22.3 right now not considered a decimal number?
Quotes.
It's the quotes, right? So it's just, the moment we put it into quotes, we're saying, computer, by the way, this is a 2, a character 2, followed by another character 2, followed by a character period, followed by a character 3, right? So it looks like a float number, but right now it's just considered a string. So these are some of the pitfalls that we can fall into, especially when we start coding. So just understanding the difference between integer, a float, and a string. Then we start looking for data. You'll see places that either give you everything as strings or actually give you nicely things that actually have been done as numbers and floats. So we'll fall into that a little later. Now, you can actually have one value, or you can have a collection of values. If you have a straight line of values, just a collection of the same type of values together, that's what we call a list or an array. Usually list has a more specific name, but array is the more technical one, but it's just basically a collection of single values, right? So far, so good. Now, this is opposite to what a data or an object is, right? The difference between a list or an array and a data object is they're both collection of attributes, right? So this one's just a collection of attributes, but usually a data object can have a mix and match of different types of collection values, right? So, for instance, a record or an object could be a student, right? So it could be, Molly, and then term, 7th year. So the first thing is a string. Then what term? 7th. So that's a number. Then age, grade. So it could be a combination of numbers and letters and the length could actually be different. Whereas somebody might have an address that's 3 lines. Some people might have addresses that's 5 lines, right? So the length of a record or an object can be different for each person. Versus usually when we have a list or array, it's just a single collection of same type of values. Now, the world is just usually a collection of these objects, these data records just floating around. So what we want to do is put it in context as something that we understand. We want to put it in some kind of order. So the way we usually do this is usually by creating tables, right? A table is nothing but a collection of records, right? And remember, a record is nothing but a collection of different data attributes, right? So a table versus a record table, just slightly different terms. A table usually has the same number of columns for every single record right here. So you see this guy right here? So let's say everybody has a first name, everybody has a term. If everybody has exactly the same amount of information, then that usually creates fairly clean tables. Okay? So usually when we do download data, most of the stuff comes in tables, in spreadsheets, and everybody has a column, and if anything, you will find gaps. So if somebody doesn't have the 4th line of address, they would still have a column for the 4th line of address. Some people would just have a gap there because they didn't need the 4th line of address. Now that versus a record table where you have a collection of records, in which case it's somehow you just have this managed collection of data objects. That can happen a lot with databases. If you start talking about databases, where you grab a database and you start saying, okay, give me all the attributes, how many attributes do you have, and start dealing with them, okay? For the most part, we're not gonna deal with this thing. We're gonna be in this world, the world of tables, okay? We're gonna do a couple of tutorials of processing. We're gonna load tables, we're gonna work with tables. We usually start with spreadsheets, and the way we communicate these things back and forth is usually through CSV files, comma-separated values. So there are tables where each of the values is separated by a comma, and usually has the same number of values, so basically the same number of commas per line. Now, just because that's what we deal with, internally there could be more interesting structures, right? There could be ways of grouping things. Like for instance, we could say, okay, all the interaction majors, but also refers to all the graphic design majors. All the, the first term versus the second term versus the third term. There could be hierarchies, ways of grouping things. Now internally, data can come in those kind of ways. You might not be able to download data sets that is just here the records of all students. You have to download all the interaction design, all the graphic design, so they might come already separated. And then you need to find either a way to just kind of mesh them up together into some kind of record table, just a bigger table, or you need to figure out a way of dealing with these hierarchies. Okay? And a hierarchy just means some structure where there's kind of like a destiny. And it gets even more complicated. There's this thing called relational databases, where records are pointing to records over there, and this is pointing to things over there. For now, we want to avoid this, right? If you look for, for some of the crime data that we got for the project, was actually saying, okay, this thing has this code. So for that code, it made no sense unless you refer to a code database, and then we could actually, say, okay, this actually means, assault. This actually means just domestic violence. So having to jump to a different database, that requires a little more skill, a little more hacking. So hopefully we can stay within this world of simple lists. Okay? So our first exercise that we're going to start right now is building up a little database, just a little tiny database. So what I want you guys to do is we're going to split up in pairs, and you guys are going to have 10 minutes to come up with a top 10 list. Top 10 whatever you want. Just get online, search for something, and put it together. Okay, and then when you're done, the next thing I want you to do is just to put it in the Dropbox.